Hello everyone, I am Sai from CSIT. Today in this presentation I am going to explain about the random vectors and its probability function. We are going to learn about the developing the notion of random variable, numerical data and discrete random variables and their probabilities. There are two types of random variables. A random variable is a variable that assumes numerical values associated with random outcome of an experiment, where one numerical value is assigned to each sample point. There are two types of random variables. A discrete random variable can be assumed as a countable number of values, number of steps to the top of the Eiffel Tower. Example: a continuous random variable can be assumed as any value along a given interval of a number line. For example, the time a tourist stays at the top of once he gets there. Some examples of discrete random variables are number of sales, number of calls, shares of stocks, people in line, mistakes per page. The examples for continuous random variable are length, depth, volume, time, and weight. Probability distributions for discrete random variables. The probability distribution of a discrete random variable is a graph, table, or formula that specifies the probability associated with each possible outcome. The random variable can be assumed as p of x is greater than or equals to 0 for all values of x. Sigma p of x here is 1. Say a random variable x follows this pattern. P of x is equals to 0.3 into 0.7 to the power x minus 1 for x is greater than 0. This table gives the probabilities rounded to 2 digits for x between 1 and 10. The mean or expected value of a discrete random variable is given as mu is equals to E of x is equals to sigma x px. The expected values of discrete random variables. P of mu minus sigma is always x always lies between mu minus sigma and mu plus sigma, and P of mu minus sigma is less than or equals to x less than or equals to mu plus 2 sigma. P of mu minus 3 sigma is less than or equals less than x less than mu plus 3 sigma. In a roulette wheel in a US casino, a $1 bet on even wins $1. If the ball falls on an even number, the odds of winning this bet are 47.37%. Probability of winning $1 is equals to 0.4737. Probability of losing $1 is equals to 0.5263. Here mu is equals to $1.4737 minus 1.5263 is equals to minus 0.526. Sigma is equals to 0.9986. Properties of binomial distribution. The fixed number of trials, two outcomes in a trial, success or failure. Trials are independent. Probability of success P remains constant. Here you can see the tree diagram of throwing a die and spinning a coin. There are 5 things you need to do to work out a binomial story problem. First thing, define success first. Success must be for a single trial. Success is equals to rolling a 6 on a single die. Definitely the probability of success is equals to 1 by 6. The probability of failure is equals to 5 by 6. Define the number of trials n is equals to 3. Define the number of success out of those trials is R. The general binomial probability formula. Here you can check the formula given. In this formula, R denotes the number of successes out of those trials, N denotes the number of trials, P is the probability of success, Q is the probability of failure, where Q is equals to 1 minus P. The general binomial probability formula. Probability of k out of n ways is given as n factorial by k factorial into n minus k factorial into p raised to the power k into 1 minus p raised to the power n minus k. Let's talk about the mean and variance. Mean is equals to np. Variance is sigma square is equals to variance of x is equals to npq, where q is equals to 1 minus p. Let's talk about the Poisson distribution. The Poisson distribution is a discrete probability distribution for the counts of events that occur randomly in a given interval of time. The Poisson distribution can be used to calculate the probabilities of various numbers of successes based on the number of successes. In order to apply the Poisson distribution, the various events must be independent. Many experimental situations occur in which we observe the counts of events within a set unit of time, area, volume, length, etc. For example, the number of cases of a disease in different towns, the number of mutations in a set seized regions of a chromosome, the number of dolphin pod sightings along a flight path through a region, the number of particles emitted by a radioactive source in a given time, the number of birds per hour during a given day. The formula for the Poisson distribution is e raised to the power minus mu into mu to the power x by x factorial, where e is the base of natural logarithms which has a value of 2.7183. Mu is the mean number of successes and x is the number of successes in the question. For example, the average number of homes sold by the Acme Realty Company is 2 homes per day. What is the probability that exactly 3 homes will be sold tomorrow? So, this is a Poisson experiment in which we know the following: mu is equal to 2 and x is equal to 3. Since e is a constant equal to approximately 2.71828, we plug these values into the Poisson formula as follows. Thus, the probability of selling 3 homes tomorrow is 0.0180. For example, suppose you know that the mean number of calls to a fire station on a weekday is 8. So what is the probability on a given day, weekday, there would be 11 calls. Here the mu is given as 8 and x is 11. When we know the e value, p is equal to e raised to the power minus 8 and 8 to the power 11 by 11 factorial, which gives the value of 0.072. Changing the size of the interval. Suppose we know that births in a hospital occurring randomly at an average rate of 1.8 births per hour. What is the probability that we observe 5 births in a given 2-hour interval? Well, if births occurs randomly at the rate of 1.8 births per hour, one interval, then births occur randomly at the rate of 3.6 births per 2-hour interval. Let y is equals to number of births in a 2-hour period. Here the p of y is equal to 5 is given as value 0.017368. The sum of two Poisson variables. Now suppose we know that in a hospital a births occur randomly at an average rate of 2.3 births per hour in a hospital. B births occur randomly at a rate of 3.1 births per hour. What is the probability that we observe 7 births in a total of from the 2 hospitals in a given 1-hour period? So if we let x is equal to number of births in a given hour at hospital A and y is number of births per hour at hospital B, then p of x plus y is equals to 7 is equals to e raised to the power of minus 5.4 into 5.4 into raised to the power of 7 by 7 factorial, which gives a probability of 0.11999. Let's go for the cumulative Poisson probability. A cumulative Poisson probability refers to the probability that a Poisson random variable is greater than some specified lower limit and less than some specified upper limit. Let's go for the normal distribution. Here the z is given as x minus mu by sigma, where x is a normal random variable, mu is the mean of x, and sigma is the standard deviation of x. Standard normal distribution. The standard normal distribution is a special case of the normal distribution. It is a distribution that occurs when a normal random variable has mean of 0 and a standard deviation of 1 standard score. The normal random variable of a standard normal distribution is called a standard score or a z-score. Every normal random variable x can be transformed into a z-score via the following equation, where x is the normal random variable, mu is the mean of x, and sigma is the standard deviation of x. And standard normal distribution. First, we transform Molly's test score into a z-score using the z-score transformation equation. Z is equal to x minus mu by sigma, which is equal to 940 minus 840 by 100, which gives the probability of 0.90. Then using the standard normal distribution table, we find the cumulative probability associated with the z-score. In this case, we find p of z less than 0.90 is equal to 0.8159. Therefore, the p of z is greater than 0.90 is equal to 1 minus p of z less than 0.90, which means 1 minus 0.8159 gives 0.1841. Thus, we estimate that 18.41% of the students are tested had a higher score than Molly. So this is the end of the Tech Talk today. Thank you.